Hi kids, thanks for watching. This video is on the new variables that we're going to be using to describe what's happening inside of a circuit from a mathematical perspective. Heads up, this video has a lot of really important information that should be new to you, especially all of these different variables. You're definitely going to want to make sure you're taking notes on this video. I think it's going to be a struggle without that. You also might want to make some flashcards with these variables to practice, because really kind of internalizing the definition of these variables is super important for this unit. The essential question for this video is what variables can describe and explain what is happening inside of a circuit. So we're going to start off by actually talking about what's really happening in circuits. Remember that when you see slides that have asterisks on them, that means that we're leaving something out of our story for the sake of simplicity. But for a change in this unit, or this video, we're going to start by talking about what's really happening and then give you the models and the analogies afterwards. So reminder that electrons exist in every atom. And what makes up a circuit is wire, battery, and resistor, all conductors. So those atoms have electrons, which are all at a state of equilibrium, which means the electrons are relatively evenly spaced. They're repelling each other, so they're spread out through the entire circuit, and they can move freely between the atoms. When the switch closes the circuit, a chemical reaction inside the battery pushes electrons from one side of the battery to the other, which becomes a negative pole. We call these electrons energized because they're packed together with each other and they want to repel. Now there's something inside a battery called a salt bridge that prevents electrons from going backwards through the battery. So we end up with a big pile of electrons on one side. The other side of the battery, of course, has an excess of protons, which is very attractive to this pile of electrons. It can't go through the battery, but since we have a conductive path of resistors and wires, those electrons rush through the circuit to try to get back to the other positive side of the battery. When those electrons go through the resistors, the energized, piled up electrons give up their excess energy, which is transformed into other kinds of energies in those resistors. Okay, so now let's use an analogy to make a circuit a little bit more approachable. An analogy that works really well for circuits is that circuits are like a school day. The students in a school day act like electrons. They move throughout the day. Those students start at their houses, which is similar to a battery in a circuit, and that is the location where they get the energy that allows them to move through the school day. Hallways and roads and things that you move through are like the wires in a circuit. They're paths for students to get from place to place. And an exam or a test that you're taking is like a resistor. It's a place where the students deposit or transform their energy into something useful. So in a circuit, the resistors are where the electrons use up their energy. In a school day, the exams or tests are the places where the students use up their energy. Okay, so there's a handful of circuit variables that you guys need to get in your notes and memorize the definitions for, and the units and the symbols to help you really understand what's going on in circuits. The first is something you may have heard before, which is voltage. We use the symbol V to represent voltage, and the units of voltage are joule per coulomb or the volt. You'll recognize joule as something we talked about briefly in our energy unit. Joule is the amount of energy. And the coulomb, of course, from the couple slides ago, or a couple shows ago, is the unit of charge. So a joule per coulomb is the amount of energy that each electron is storing. So for example, if we have a battery that gives off 60 joules of energy to 4 coulombs of electrons that are passing through, the voltage of that battery is 15 joules per coulomb, or 15 volts. The second variable that we use when talking about circuits is current, and for some reason they use the variable symbol I to represent current. The units of current are coulombs per second, otherwise known as an ampere, which is sometimes abbreviated amp or just capital A. Of course, you'll recognize that a coulomb is, again, the number of the unit of charge, and a second is time. So current is defined as the number of electrons each second that are passing through a location. So for example, in 120 seconds, 30 coulombs of electrons are passing through a resistor, which means the current is going to be 30 coulombs per 120 seconds, which simplifies down to 0.25 coulombs per second, or 0.25 amps. The third circuit variable is the resistance, which is a capital R of a resistor or of the entire circuit. The units are really ugly there, joule second per coulomb squared, but you never see it written like that. The units that you'll always see are called the ohm, OHM, which is a Greek letter, and it's written like a little upside down horseshoe. The resistance of a element or a circuit is basically how difficult it is for the electron to pass through some part of that circuit, usually the resistor. So for example, a 4 ohm toaster and a 1 ohm coffee maker are in a circuit. Which one has more resistance? Should be pretty straightforward that the toaster is 4 times harder to get through for electrons. And the last circuit variable is, I will say, the most important one. And that's because all the conservation principles kind of come into play in this last variable, and understanding what happens in this last variable is kind of crucial to understanding what's going on in the whole circuit, and that is power. Power is written with a cursive P, capital P, and the units are joules per second. Again, joules is the units of energy, and second is time, so that's the amount of energy that's being transformed into something else every second. Sometimes joule per second is shortened to a watt, which is a capital W, which is another unit for power. So for example, in 30 seconds, a light transforms 90 joules of energy into light, which means the power is 90 joules per 30 seconds, or 3 joules per second, or 3 watts. So let's revisit the essential question from the beginning of this video. What variables can describe and explain what is happening inside of a circuit? And then I would like to encourage you guys to make some circuit variable flashcards and practice just quizzing yourself about the 4 circuit variables and what the units are, and solving some little practice problems that look like the ones that I put in this slideshow to get ready to be able to recite quickly what each variable stands for. Thank you.